Hello, you are most welcome. I'm teacher Ivan from Wuuna Educational Services, and I welcome you to today's lesson. In this particular lesson, we shall be looking at O-level physics calculations from the topic of pressure. But before we go to calculations in pressure, you must also read and acquire knowledge about the following. Number one, you must be well versed with the definition and the SI unit of pressure. You must also acquire knowledge about the applications and how we obtain or calculate maximum and minimum pressure. Still, you must also research and acquire knowledge about the factors that affect pressure in both liquids and solids. The variation of pressure in liquids. How does pressure vary with the cross-sectional area and maybe the depth? Still, we need knowledge about Pascal's principle. Sometimes it's known as the principle of transmission of pressure and its respective applications. We still need to get knowledge about the applications of atmospheric pressure. However, before you look at applications, first define what atmospheric pressure is and the various units in which atmospheric pressure is measured. There is quite a number of units that we use in measuring atmospheric pressure, and how we convert from one to another, it's very important. And lastly, this is what we are going to do, measuring pressure. So, in measurement of pressure, we look at some important formula that we shall be using as we work out certain examples on pressure. These important formula include the very formula for pressure from its definition, which is from force over area. Since pressure is force over area, that means that we can also derive its units. Since force is in newtons and area is in square meter, therefore one of the units of pressure is newtons per square meter. However, when I divide 1 newton by 1 square meter, I get 1 Pascal. So Pascal is the SI unit of pressure. And that means that it is very important for you to get the definition of a Pascal. Please do that. And then we also have the maximum and the minimum pressure. How do we calculate maximum pressure and how do we calculate minimum pressure? Besides that, you must also be knowing their respective applications. Maximum pressure is given as force over minimum area, whereas minimum pressure is force over maximum area, meaning that the force is kept constant and it is the cross-sectional area or area of contact that affects the pressure. That is how we shall be getting maximum and minimum pressure. Then we also have the derivation or the expression of pressure in fluids, that is liquids and gases. So you must know how to derive this expression for pressure in liquids or fluids. Those are some of the most important things that you need to know about pressure. Then let us go straight to our examples. Example 1 is telling us that a man of mass 84 kilograms stands upright on a floor. And if the area of contact of his shoes and the floor is 420 centimeters squared, we are required to find the pressure he exerts on the floor. So, from the definition of pressure, we were able to come up with the formula for pressure, whereby pressure is given as force over area. So, since we have mass, we can be able to get the force. And since this man is standing, therefore, the force he exerts on the floor is equivalent to his weight. And therefore, the force is given as mg, and then the area. So that will give us the mass is 84 kilograms times the acceleration due to gravity, which is considered to be 10 over the cross-sectional area. Perhaps our area is in centimeters squared, which is not the standard unit, and therefore we must change. So we are saying this divided by 10,000, we are changing from centimeter squared to meter squared. So that is how we shall find the pressure. Please, you can continue, can go on to use a calculator and manipulate to come up with the exact figure for the pressure. Whatever figure it will be, it must be in either Newton per meter squared or in Pascal. Otherwise, let's move on to our second example. In the second example, we are given the dimensions of a cuboid, which is 5 centimeter by 10 by 20. And the weight of the cuboid as 60 newtons. So our task is to calculate the maximum and the minimum pressure. But don't forget that maximum pressure is given as the force over minimum area, whereas minimum pressure is given as force over maximum area. And that means that we need first get minimum area and maximum area. Good enough, we are given the dimensions. Let's try to sketch a cuboid and then indicate the dimensions. That is our cuboid, and then assuming this is the 5 centimeters, this is the 10 centimeters, and this is the 20 centimeters, meaning various faces of this cuboid can be put in contact with the floor. And assuming we first use this face, we shall consider these dimensions to get the area. So this will give us area 1 when we use this face in contact with the ground or the floor. We can also use this face to give us area 2. Or we can use this face to give us area 3. Therefore, Area 1 will be given by, this is 5 centimeters by 10 centimeters, since area is length times width, which will give us 50 centimeters squared. Then we also look at area 2. Area 2 is when we are considering this face in contact with the floor. This is 20, this one is 5 centimeters. And therefore, the area 2 is given as 5 times 20, which is 5 centimeters times 20 centimeters, giving us 100 centimeters squared. Or we can consider this face, but this one is equivalent to this, meaning we also have 10 here, and this is equivalent to that, meaning this is 20. So therefore the area of this face will be 10 and 20. So area 3 is 10 centimeters times the 20 centimeters to give us 200 centimeters squared. And now we shall determine out of these 3 areas which one is maximum and which one is minimum. Perhaps that is one way. Someone will choose not to draw and show the areas, but just to multiply any 2 of the dimensions given. You can first multiply this and that, then 5 and 20, then 10 and 20. Meaning that each value here multiplies the other 2. This multiplies this and also multiplies this. And then this multiplies this and also multiplies that. Then from there we can determine which one is giving us the biggest value of area. And therefore, from what we have worked out, this is our minimum area and this is our maximum area. Then we come, so we shall say our minimum area is 50 centimeters squared and our maximum area is 200 centimeters squared. Then we come to force. Force is given as mg in this case, since we are talking about the weight. But the weight is already given as 60 newtons. So it is just a matter of now substituting in our 2 formula, meaning that for maximum pressure, we are using the weight 60 over minimum area of 50. But don't forget to change 50 centimeters squared in meters squared. We divide this by 10,000 because 1 meter is 100 centimeters. Therefore, if we square, we get 1 meter squared equaling to 100 times 100 centimeters squared, which is 1,000. So we shall divide this and that by 10,000 to change them to meters squared, then substituting our formula so that we may be able to get the maximum and minimum pressure. Otherwise, the other examples are still on the way and we shall have them in our next video. So please subscribe and hit the bell such that you don't miss any of the lessons. Otherwise, I'm Teacher Ivan from Wuuna Educational Services. We have other platforms on YouTube, Facebook, and TikTok. Search for Wuuna e-learning platform, Wuuna Kids platform, Teacher Ivan's online class, Wuuna math channel on all those platforms. Join them so that we learn together. Otherwise, bye-bye.